My name is Samantha Berman, University ID number 205304608. So for question 1 of the final exam, it was the three reservoir problem. And so overall in this problem, there were 9 unknowns. It was the 3 Reynolds numbers, the 3 friction factors, and the 3 velocities in the 3 sections of the pipe. And so I found 9 equations, and this would be solved in an iterative process. And so after drawing my picture, and I calculated the area of each, the cross-section of each pipe, and then at the central node, you could sum all of the head losses from each individual pipe. And then I found the governing equations for the head loss, which was the friction factor times the length of the pipe times the velocity squared, divided by the diameter divided by 2g. And so that was the second equation, was the head loss equation for each pipe. The third equation came from the continuity equation, so Q1 equals Q2 plus Q3. The sum of the flow rates must be summed. And so V1A1 equals V2A2 plus V3A3, and this found a relationship between the velocities in the 3 pipes. And then I found the Reynolds numbers and the roughness of each pipe. And these numbers would be used with the Moody chart to find the corresponding friction factor. But we have an unknown friction factor and an unknown velocity, and so this would be where the iterative process is introduced. There's also the Kohlberg equation, which could be used for each pipe, or for each section of the pipe, with the corresponding friction factor and Reynolds number at each, and roughness for each segment of the pipe. And then the energy equation provides another 3 equations. And so all surfaces are free surfaces, so the pressure is atmospheric pressure and 0 gauge. And the velocity within the tank is 0 due to the Bernoulli's equation, because it's like a larger area than compared to like the smaller pipe, and so you can assume that the velocity at the top is going to be 0. And so this provided an additional 3 equations that relate the heights of the free surfaces to the head loss in each pipe. And so these are the 9 equations with 9 unknowns. And then after finding the velocity at within each pipe, you can find the volume flow rate within each pipe.